On October 7, 2025, the European Space Agency released what they called the first official image of 3I Atlas, an interstellar object caught gliding past Mars. The world had waited for a revelation. Instead, we received a blur, a faint, flickering dot drifting in a black sea of pixels. But what followed was stranger than the image itself, a 4-day silence from every other major space agency. NASA, China, the U. All quiet. Why would every agency with better cameras, better sensors, and far more powerful telescopes suddenly vanish from the conversation? While ESA alone tried to explain chemistry that shouldn't exist, a trajectory too precise, a coma almost entirely made of carbon dioxide, and a silence heavy enough to make the world wonder, what exactly are they seeing? If 3I Atlas were just another comet, every question should have an answer. Instead, every answer led to more questions, and somewhere between the official press release and the missing data, the truth began to slip through the cracks. Just 5 days earlier, on October 2nd, something happened on the surface of Mars, far from ESA's labs and headlines. At 9:18 in the morning, local Martian time, NASA's Perseverance rover captured an image that was never meant to matter. Its SkyCam, a wide-angle color imager designed to watch dust storms, not comets, recorded a single frame showing a tiny green-circled speck in the Martian sky. It shouldn't have seen anything. Daylight on Mars is brutal. Dust scatters sunlight like fog, drowning faint objects in glare. But one shift-lead, Mallory Leffeland, refused to power the camera down. With the U.S. government shutdown threatening to suspend operations, she insisted they keep SkyCam running, just in case. That decision changed everything. The raw frame, time-stamped and archived, became the first confirmed evidence that 3I Atlas had entered Mars's neighborhood, the first interstellar object ever photographed from another planet. It was noisy, grainy, barely visible, but it was real. That single pixel anchored a mystery no one was prepared to face. A mystery that would soon pull 7 spacecraft, 4 nations, and countless scientists into silence. By the next sunrise on Mars, the world's eyes had turned toward the red planet. On October 3, 2025, 7 spacecraft, each orbiting Mars, each built for a different purpose, found themselves in position to witness something unprecedented. An interstellar visitor brushing past another world. It wasn't planned. It wasn't coordinated. But fate, geometry, and a little luck had drawn them all into alignment. The Mars Reconnaissance Orbiter's high-rise camera, famous for capturing landscapes sharp enough to reveal a rover's tracks, tried to thread a cosmic needle to catch a moving comet smaller than a city 30 million kilometers away. Its view was narrow, its timing critical. Even a half-second delay meant missing everything. The ExoMars Trace gas orbiter, with its KSS-ES imaging system, played the long game, stacking multiple faint exposures, sacrificing sharpness for sensitivity. Meanwhile, NASA's Odyssey turned its infrared detector toward the predicted path, hoping for a hint of heat, though comets are rarely warm enough to be seen that way. Mars Express joined in with 2 spectrometers, Omega and SpyCam, dissecting the coma's invisible gases. Their goal? Identify fingerprints of water, carbon dioxide, or something stranger, compounds that could tell whether this object was forged by nature or by something else. From much farther away, China's Tianwen-1 orbiter brought radar and multispectral sensors into the mix, able to probe beneath dust and ice if the angle was right. And from an even higher orbit, the UAE's HOPE probe watched in ultraviolet and optical wavelengths, sensitive to changes in the comet's brightness and shape. For a few precious hours, Mars became the most scientifically crowded sky in the solar system, a perfect storm of instruments pointed at a single target. Each probe faced brutal odds, faint light thousands of times weaker than the Martian sun, short exposure windows, and a target moving faster than any local body. But still, they tried, and somewhere in those hours of raw data, buried in noise, cosmic rays, and calibration errors, the truth was hiding. Then silence. ESA promised a public release soon. Days passed. Then, on October 7th, the world finally saw it. Not a majestic comet blazing through the stars, but a tiny moving dot wrapped in a ghostly haze. The animation was beautiful in its simplicity, a faint breath of motion in an endless dark field. But it wasn't just a picture. It was proof that 3I Atlas had been there, and that someone, somewhere, was holding back the rest. What followed the ESA's release was not celebration. It was silence, heavy, deliberate silence. On October 4th, 2025, mission leads from NASA, ESA, China's CNSA, and the UAE gathered for a confidential teleconference that never appeared on any official calendar. No transcript, no recording. But within hours of that call, something changed. Every agency with eyes on Mars went dark. For 3 days, no images, no statements, no data. Only the European Space Agency spoke, releasing a single, cautious animation and a bland paragraph promising further analysis. NASA blamed the U.S. government shutdown, claiming that only essential operations were allowed to continue. But that didn't explain China, or the UAE, or why even ESA's own spectroscopic data suddenly fell under a 6-month embargo. Inside the agency, tension brewed. Public relations teams pushed for a dramatic reveal, a historic image to match public expectations. But the scientists and the people who read the raw files said no. Memos circulated with phrases like potential for misinterpretation and need for interagency review, the kind of language reserved for planetary defense alerts, not for a comet. Drafts were written, revised, then stripped of every mention of anomalous chemistry. Words like unexplained optical effects vanished. In their place came cold, bureaucratic reassurances, normal variability, routine calibration, pending confirmation. But behind the silence, fear was growing. Even among scientists, whispers spread. Not of aliens or conspiracy, but of data that didn't fit. Polarization values off the charts, chemical ratios never seen before, and perhaps worst of all, a trajectory that looked too perfect to be random. Independent analysts noticed something else. This level of coordination, 4 rival space agencies withholding everything, had no precedent outside of asteroid impact threats. The last time they'd done something similar, the object in question was large enough to raise fears of planetary risk. But 3I Atlas was no threat. So why act as if it was? Maybe they weren't hiding danger. Maybe they were hiding confusion. Something that broke the models, that couldn't be explained without rewriting the rules. Whatever the reason, one truth was becoming clear. The story of 3I Atlas was no longer just about a comet. It was about what humanity chooses to reveal and what it decides to keep in the dark. By mid-October, the silence had become its own kind of noise. Rumors swirled through the astrophysics community. Fragments of leaked memos, whispers about non-standard chemistry. And when ESA's internal documents surfaced weeks later, the pieces finally began to fit. The trajectory of 3 Atlas made no sense. ESA's Space Situational Awareness Office calculated that the odds of a random interstellar object following such a precise path, passing within 5 degrees of the ecliptic between Mars in October and Jupiter by March, was less than 1 in 10,000. Even more unnerving, the flight path brushed directly past the coordinates of the 1977 WOW signal. Officially, it was pure coincidence. But behind closed doors, no one believed in coincidence anymore. Then came the chemistry. Spectral readings from the Very Large Telescope, VLT, and JWST revealed something almost impossible. Strong atomic nickel lines without any trace of iron. In every known comet, nickel and iron travel together, released from dust grains by sunlight or heat. Here, iron was gone, while nickel increased exponentially with proximity to the sun. By late August, the VLT logged a nickel production rate near 10^22 atoms per second, falling off so sharply with distance that it outpaced every known model of cometary activity. Lab simulations offered one disturbing explanation: nickel carbonyl, a volatile compound that forms in carbon monoxide-rich environments and breaks down under mild heat, releasing pure nickel gas. On Earth, that's an industrial process. In space, it shouldn't exist. Meanwhile, JWST's near-infrared spectrometer found that the comet's coma, the glowing cloud around its core, was 95% carbon dioxide. Water, the most common cometary element, barely registered. Some theorized that long exposure to interstellar radiation had stripped away the water ice. Others, more quietly, wondered if the CO2-rich signature hinted at something deliberate: propellant use, controlled venting, or even engineering. But there was no proof. Only numbers that refused to behave. Optical polarization data made things even stranger. Both KSS's and VLT's 4S2 detected extreme negative polarization, values of % or more at red wavelengths. That means the coma's dust wasn't scattering light like ice or rock. It was backscattering, a behavior linked to ultra-fine carbon-rich or metallic particles. In known comets, polarization rarely dips below 2 p. 3I Atlas nearly doubled that. And every recalibration, every control run against standard stars confirmed the readings. It wasn't an error. It was real. Taken together, the evidence painted a picture that defied nature. A trajectory too precise, a chemistry that echoed industrial processes, and light that behaved like it was reflecting off engineered material. Each anomaly could be explained away, statistically, chemically, or physically. But together, they formed a pattern too perfect to ignore. Something about 3I Atlas was different. Something about it felt designed. And the closer it drew to the sun, the stranger it became. As October drew to an end, the world's view of 3I Atlas vanished. Between October 29th and mid-November, the object slipped behind the sun, hidden by plasma, radiation, and a glare no instrument could penetrate. For 2 weeks, every telescope, every probe went blind. That blackout wasn't just an inconvenience. It was an erasure. The moment when comets usually reveal their true nature, when they flare, fragment, or, if they're not comets at all, change course. But no one could see. No radar, no light, no data. Just silence. 4 hypotheses now compete for the truth. The first, the most cautious, insists 3I Atlas is simply a natural comet, rare but explainable. If that's true, it will behave predictably after the blackout, shedding gas and dust in familiar ratios, revealing traces of water and iron once hidden by distance. The second dares a different idea, an ancient artifact, a relic from somewhere beyond the stars, drifting dormant until solar heat awakened its chemistry. Nickel carbonyl, carbon dioxide dominance, negative polarization, all could fit if its surface was once engineered. The third model views it as a probe, deliberately steering through planetary alignments to study us, its trajectory optimized for flybys rather than chance. But so far, no energy signatures, no telemetry, no signs of control. And the fourth, whispered by only a few, a hybrid, a shell of natural material wrapped around something not natural at all. A disguise. If that's true, only the data waiting behind the sun can prove it. Late November, ESA's JUICE spacecraft will aim its high-resolution Janus camera toward Jupiter's sky, where 3I Atlas is predicted to reappear. A few months later, Juno will follow from its polar orbit. If either probe captures even a hint of deviation, a shimmer of motion that isn't gravitational, everything changes. For now, the story is paused. The interstellar visitor drifts unseen behind the sun, its secrets sealed in light we cannot reach. The agencies wait, the scientists wait, and so do we. Because sometimes, the most important discoveries are not the ones we witness, but the ones that vanish, right when we're about to understand them.